Hi guys, HC605MA here, and in this video I would like to talk about using Simchair software for driving your own devices. So I have been asked a lot about how to modify the software to use for something for some other hardware that guys make, and I decided to try to make a video about how one can easily do it, and to talk about the structure of the software, and to show you how it can be done on some basic and simple device. So here we have our master controller, the new one. I will talk about it in a separate video. Our sample device, it's a simple Arduino Uno with the I2C socket and the button here, and the cable to hook them together. So this video, this will be an impromptu video, so sorry guys if it will be a bit rough. It will be targeted to newbies, but guys that are comfortable with Arduino may find something useful in it, because I will also be talking about some structural things and the firmware in general, the Simchair firmware in general. So where should you start if you are a complete newbie and you want to build your own joystick based on Arduino? It's first, it's not hard. You can do it, absolutely you can do it. You just need to read a bit about stuff, and then you need to carefully look at Simchair firmware, because it contains everything you need. It contains everything joystick related that can possibly exist. It's the whole firmware is a huge example of how you can make a joystick out of with any desired functionality you want. So you just need to look at it, and we will do it together. I will explain what is where and where to look, and then using some general Arduino documentation, you can dive deeply into what's happening on every tab, and understand what's happening there. It's fairly easy, as everything is split into tabs. So I will describe each of them, and then we'll look at the peripheral file of each device, and we will look at what can be taken from where to suit your own joystick. So let me start with talking about the Arduino in general. First, you may want to look at some basics, to read some introductory stuff about Arduino, how to use it, how to write simple programs with it, like maybe blink, or to read the potentiometer, or stuff like that. So start with basics. In short, Arduino lets us, joystick wise, it lets us to read or write its pins here. This so we may read values of what's connected to our pins and send it to the PC, or we can read something from our PC and do something with it, but this is a whole different topic for another video. It's not implemented in Simchair at the moment. So first step, let's read the basics. When you're comfortable with Arduino stuff a bit comfortable when you can understand what the variable is, what is the global variable, the local variable, the structures, the oops. So stuff like that, programming basics. These things are similar across a lot of programming languages. So make sure you are comfortable with this basic, stuff before you proceed. It will make your life a lot easier. Then, when you have read about the basics, let's look at the firmware structure. You can see that we have files here that are named. Each file has a letter preceding its name. So this is done because all these files are glued into one file during compilation. So let's open the master. So all the stuffs become a single file when you press the compile button. Let's look at what's happening on each tab here. So the master file here we have just includes when in this file, because Arduino IDE requires us to have a file that is called the same as the directory that it is stored in. So that's just that we have includes here. Again, about what's includes, you need to look at the basics. If you don't understand what is this here, this is basically this loads the external libraries. They become the part of this sketch when you load them. You can use their their functions, their objects in the code after you load them, like this. So the device definition step. Here we have define statements for our system. We can enable or disable devices. So we have cyclic base, be it grip, simple collective, and and that's it, enabled at the moment. So to enable device, you uncomment it, for example, like that. If we want a pedestal, I don't have one at the moment, but we can enable it for example. That's it, it's enabled. After you flash your master controller, it will show the pedestal joystick. Here we have disabled it again. This is the command sign, but you should know that already after you have read the basics about Arduino stuff. Now let's move on to structure step. These are structures for certain devices. Structures, again, you can find what they are in Google. Nothing other, just sets of variables of the same type, which can be easily accessed in in a comfortable way. Not of the same type, but of here we have different types. But anyway, doesn't matter. Just look at the menu if you are not comfortable with structures. If you want to know what they do, it's just a definition of some variables. Configuration tab. Here we have configurations for all our standard devices. Constants, mainly I2C addresses of stuff. global vars. This is just that, the sets of global variables needed for devices, for various devices, and they are loaded. You can see that they are loaded when you enable the device in device definition step. So setup tabs, setup begin tab, which contains just the word void setup, and the this just begins the setup subroutine, the setup sub body. So you can see that here we call the if some device is enabled, we use the delay, because otherwise it causes problems on startup. If you don't use this delay, chances are that stuff won't work under Windows. Then we call the setup subroutine from each device, each enabled device stop. So each device has its own tab in the master controller firmware, and we call this subroutine from this tab for each device. You can see stop simple pedestal, stop compact collective. So if the device is uncommented on the device definition step, we run the setup sub for each enabled device, and only for enabled devices. So this ends the setup sub and begins the loop sub, which is the main loop of the program. You can see that here we have the same thing, but we call poll subroutine for each device, for each enabled device again. If defined, we call poll, and we define them in device definition step. Here it's simply the end of the main loop. So why are these files so weird? I mean, you can see we don't have a lot here, right? And for example, the setup begin, it contains only one weird line. So this is that because you may want, this firmware updates frequently, so I wanted you to avoid problems and conflicts when you add your own hardware from the very beginning, and I wanted you to be able to add your own files for your device in a way that when I update the main hardware, main firmware, your device won't be interfering with with your configuration. So this basically is split into tabs, so you can add your own files between, for example, main loop begin and main loop body, or after the body. So you can add your own file, for example, fda main loop body custom something, and you can put if defined my own custom device, poll my own custom device, and that means that when you re-download, update this firmware, your this page will be overwritten with the newer version, but you will have your device in a separate file, so it won't be affected and it will work as it worked. This is the idea. I will of course show you the whole process later in this video. So then after this is basically all we have structure wise. Then it's just device tabs. So every device in Simchair has two parts. It has the master controller file, which is basically the device tab in master controller firmware, like this simple pedestal. You can see if defined simple pedestal, if the device is enabled, we create a joystick object, we we start it, we define its access ranges, and here is the poll subroutine, which is called in the main function, and yeah, and here is the setup subroutine that is called from the setup page tab. So setup basically creates a joystick object, starts it, and sets access ranges, and the poll it reads data from the device. Again, I will talk more about it a bit later. So you can see if we look there, it's just device tabs, and the last tab we have is shared functions tab. Shared functions tab is, it contains the functions that are common across different devices. For example, parse head switch. A lot of devices have the head switch in them, and it usually works in the same way. So it's put there. That's it. Or for example, adjust sensitivity. Adjust sensitivity stuff. It is there because if you will have several I'm not sure why it is shared. I wanted to be for it to be common across some different devices. Never mind. Just just know that this is intended to be shared between several devices. So here we have just the device tabs. That's pretty much all about the structure. Let's look at what we need to create our own device. So we need to create a master controller tab. We need to create a peripheral file here in the Simchair software peripherals. Here we have to create a separate peripheral for our device. So so we need peripheral part, master part, then we need to put our global vars to global vars. We need some constants, we need to add our I2C address to constants tab, and we need to add some configuration options for it. We need to add structures if needed. As you can see, not every device has its structures. It's mostly for some complex functions, And of course, we need to add it in device definitions tab. So device definitions tab, configuration, constants, global vars, setup. We need, of course, to pull the setup function from our device tab and the pull function. That's it. That may seem like a lot of stuff need to be done, but it's not really. It's not that much really. It's just organization. It's just a few lines here and there. Let's look at them. So first thing that we want to do when we are creating, now we know what happens in the master. We want to write the peripheral file and we want to flash it here, and then we want to make the master part. So let's start with writing the peripheral file. I will make a copy of it. Okay, so let's call it a tutorial device. So now, first thing, we need to understand what our device is similar to. So all we have on our device is a button, right? So this is similar to, for example, the 412 head, a collective head. Basically every device is similar to a 412 collective head. Why? Because it has pretty much everything except encoders. It has two potentiometers, two head switches, two potentiometers, and a lot of switches and buttons. Alternatively, if you want, if our device had an encoder, I would look for the VRMAX pedestal software, because it has everything. It has encoders, it has potentiometer, it has a lot of switches, but for example, let's look at the 412 head. So the head has two controllers. Let's look what they do. One of them is a switch one. So basically this is the switch controller. You can see the file is really short, and if we look at the other controller B part, you can see it contains a lot of analog reads. Thus it's the potentiometer controller. So you can see how how simple the whole thing is. Basically what we have here. So again, I hope you have read some basics at this point, because it will be really much easier to understand stuff if you read something on the topic prior. So define debug. If we uncomment it, we will see some debug output when we flash it. Variables, it's x and y, b, b1, b2. These are 3 bytes. You can see they are written in binary form. What this means is we have the array of zeros. It's just that you can see that you can see what it is on the screen. So when you press the button, one of these one of these zeros becomes a 1, and then when you release the button it becomes 0 again. So where does this happen? So here we just call that B contains 8 zeros. 0B at the start of it calls that this is the binary form of the value. So first thing we do here, we call void setup. We start the I2C slave module. So we define which sub will be called when the master will ask us to send our data. It is the request event sub. You can see how simple it is. So when our master, it says device number AB412 had I2C address, give me your data please, and it says okay mate, here's your data, but I have 3 bytes for you, and you can see that our data is taken from these 3 bytes. So what happens is we do something with these bytes in the loop section, in the loop sub, and when our master wants to read the data, we simply send him our bytes as is. Okay, so now this is our request event sub. You can see that we have 3 bytes here, and the very important part in our write call, we have to have a proper number of bytes here. So if we had 1 byte here, we will put 1 here. If we have 4, 5, 7 bytes here, we will put the corresponding number in there, and we will read the corresponding number of bytes in the master later. So we have the loop function, right? And this is basically how we read our buttons. So yeah, sorry, here you can see that we initialize our pins as input pull-up pins. That means that our pins are tied to the 5-volt bus through internal built-in resistors in here. So what we have here, then minute, let's try to add some light. Okay, so the button, each button is connected between some pin and the ground. So when we have when we press our button, the button gets the pin gets shorted to the ground through our built-in in the board pull-up resistor. Okay, so that's it. The only thing left is our loop function. The loop function goes through all of our pins which we have here on the board, and we have 13 digital pins, and we can use analog pins as digital pins as well, from A0 to A5. So basically if you want to use analog pins as digital pins, you just address him as pin 14, 15, 16, 17, 18 and 19. But pins R4 and A5, they are reserved for I2C communication. So what we have is 13, 14, 15, 16, 17 pins we have on our Arduino board. And that's it. If you need more than 17 pins, you need another board. That's why in 412 head firmware, in 412 head we have two boards, one for analog stuff and one for digital stuff, because there are a lot of switches and they use the whole thing. Okay, so now finally it's time to create our tutorial device firmware. And so I do just that. I go tutorial device. I know. Okay. And now I want to copy stuff into it. So yeah, we don't need this for a while, so I will just I will just copy the whole thing, as all we need is buttons. So yeah, what happens in the loop here, I forgot to tell, sorry for that. You can see that if we have a pin, this is the loop. Again, you should have read about what loops are, what the loop is at this moment. Sorry. Yeah, so what we have here, we go through each pin and check its value. If its value is 1, the button is pressed. And if the if the button is pressed, we using some binary math function here, you can see the command forces the bit of B to be 1. So we just, what we do, we just take the number of some 0 here in this byte and set it to 1, and that's it. But what if we have more than 8 buttons? Of course we have 17, right? So we need something like that, if our pin number is less than 8, the value goes to byte B. Then if our pin is between 8 and 16, our value goes to byte 1, B1. And if the whole thing is pin 16 and 17, if the pin number is 16 or 17, it goes to byte B2. Otherwise, if the button is released, we just set it to 0 in the same way. So basically it's two lines here. That you need to understand. What they do, they set the given number of the byte, that is I, to 1 or 0, depending on what we, in what state we have our button at the moment. So that's it. That's the whole idea of reading buttons. We can close it now. Yeah, so let's adjust our tutorial device firmware. We can remove unneeded stuff. Let's call it the tutorial device here as well. So tutorial device I2C I2C address, let it be 100 100, right? Why not? So we want debug here. We don't need these 2 bytes because we only have one button. And yeah, we can leave this pins thing as is. Basically, if you just leave it like that, it will work. But we want it to be beautiful, so, and we want to do it properly, so let's adjust it. We don't need X and Y. We have 12 pins because our button is on pin 12. Yeah, so we put wire begin here on our address. This stays the same, so we need to simplify this function, and basically we can even, so our button is on pin 12, right? So what we need, we can thinking of the best way to do it for that's just remove our parts here. So what happens here, that we know that our button is connected to pin 12, so we will be putting it to byte B here, and then we can remove this stuff, and yeah, now we will have our button in the B byte. So here now we don't have these 2 bytes anymore, so we don't need them here. We will be sending just a single byte. So basically that's it. Yeah, I can from here. Let's try and look if it will compile, if it compiles. It does. So now what we want to do, we want to flash it here onto our device. So we choose the correct port, which is the COM11. We select our port, which is the Arduino Uno. We press flash. And it is done, and now we can Now we can look at what is happening here. You can see that we have, when I press the button, one pops up here. So it works. When the master will ask for our button, we'll send it to him. Now our device is basically, device file is ready, so we command this out and refresh it. It works. You know, we can adjust it slightly. For example, we can actually, no, for this particular devices we have one button. We can make it even more fun. We can, you know, you can just say doesn't matter really. It's just, of course you will have more than one button when you will be making your own devices, so you know, trying to make this you know, look better won't do anything good, especially in an impromptu video. So I will just leave it like this. In the real device you may want to move that stuff to you know, if you look at it again, you may want to move your one here to the first byte. So but let's leave this out of the scope of this video because it's a bit more, you know, it's unlikely that you will be having a device with one button. Besides, I have forgotten how to do it. Oh. Yeah. Never mind. It's just let's leave it out of the scope for now because I haven't no. I have forgot how to do it. I have to refresh my you know, binary mat and this stuff. I have to read the tutorial myself sometimes about this stuff. So let's just leave it like this. So we have our button working. We can comment out the debug. And we have our tutorial device here. So this is the time for us to create the master master file. So what we want to do, we want to create the device file. Let's call it n tutorial device that I know. Okay. Then, as I have told you earlier, we don't want our device settings and guts to be rewritten on software updates. So we will create our own separate configuration files, global virus files, and setup, and main loop file. So let's start with the device definitions file. So it will be BA tutorial device that I know. Device definition, something like that. Oh, sorry, it will be BAA. Or B0. Yeah. Now it looks correctly. So next one will be, we won't have any structures for our simple device, so it will be CA tutorial device configuration .ino. Okay, now we will have constants and global vars as well. So it will be CDA constants, CDA yeah, I suppose it's better to call files like this. So let's call it B0 definitions, device definitions tutorial device. It will be better, and this will be configuration tutorial device. This is much better. Constant tutorial device, and EA global vars tutorial device. I know. So now we need the setup file and the main loop file, and that's it. So FBA setup body tutorial device. I know. And the main loop here, so it will be FD a main loop tutorial device fine. So I'm showing the correct way of no, the correct way of making your own firmware here, because your own software for your own device here, because you can of course just add stuff to existing files, but it won't persist if you will no, through software updates it will be overwritten, so it's a pain, and I don't want you to have any more pain than is absolutely needed. So it's better to create a proper file structure once and then live with it. So you can see now we have these files as steps here empty so far. So what we need to do, we want to copy our for example, we have looked at the 412 head. Where are you hiding? Okay. So we can look at the AB412 firmware here as well, for how to read and how to work with buttons. So we can just copy the whole tab and then remove what is not needed. Where is our tutorial device? No, not here. Here. So I just copied the 412 tab and we call it tutorial device here. Tutorial device. Joystick. We of course we want to change the joystick's name to be J tutorial, or just let's go with JTD, and the number of this is the number of the joysticks of the joystick object. No, sorry, the joystick ID in Windows. So it affects the order in which devices are, occur in Windows JCPL. In game controller properties. So let's make it, for example, device 20. So it will be our, in the end of the list, and won't interfere with anything we have at the moment. So this is the device type. This is a flight stick or a gamepad. I don't remember. You can look at this on the Hieronymus joystick library page, which everything here became possible because of the Hieronymus joystick library. This library is simply awesome. Before this library it was such a pain to work with USB descriptors directly, and now it's just perfect. So, number of buttons. We have one, but we will say we have 8 because we have 1 byte with buttons. So we will see a joystick with 8 buttons. Number of head switches we have known, so we set it to 0. And access, again, look at the description of this stuff at the Hieronymus page. Let's here Hieronymus Arduino joystick library, and here is the description of it. you can see that the type 5 is a gamepad. You can see that then goes the button count, the head switch count, then x-axis, y-axis, z-axis, and all the other axes. This is you can read this description here to see what you can do with this library. It's cool. It's very well documented. So we have no access here, so we will set this to false. So we have all access set to false. Here we have 8 buttons, type gamepad, device number 20, and 0 head switches. So AB412 begin. This will start our joystick object. We have to change it for JTD begin. We don't have any access, so we don't need to set access range. Thus we will remove it. Yeah, do I still have enough space for recording? I do. So first thing, we don't need keyboard with this device. So, of course, we don't need the HUI compatibility mode. So it's just the setup sub will just start our joystick object. So it's Poll tutorial device, and this is the setup tutorial device. Okay. We only have 1 byte here, so we just say we have 1 byte B, and we don't need anything fancy. So we will just say here that we want to pull 1 byte from the tutorial device I2C address. We put 1 here to pull 1 byte. Remember, I told you it's very important to have the same number of bytes requested and sent. So on this side and on the peripheral side you have to have the same number of bytes here. So we will only receive 1 byte, so we remove everything that we don't need. So okay, now it's much better. Indentation is important, really important, guys. You know, make sure you're following the correct indentation and the correct code styling. It's, if you're new to programming, the code styling is really important. Sorry if it is not followed somewhere here. It's because of time shortage, and really the problem is I don't have enough time to revisit this stuff as often as you know, as I want. So this is just debug stuff. I can safely remove it, or yeah, this is the calibration stuff. We can safely so yeah, we can just put our B here, remove everything else. This is the head specific stuff. We can remove it safely up to the point. You can see that here we have we use parse head switch. By the way, yeah, we have to talk about it because yeah, let's discuss what we have here. maybe it's better to have it covered in the separate video, because let's talk just about the structure in this video, not about the in-depth how to read stuff, how to use pods, how to use buttons, etc., because it will make the video basically endless. So we will simply remove that. But you can see that we call parse head switch wow on the head value we receive by reading the we have removed it, but we just call the parse head switch on some value we read from our device, and then we can set it like this with set head switch and head wow. So I will make a separate video about each type of controls we may want to read and show as a joystick. So far I wanted to mainly wanted to show you how to add your own devices. So here we have the interesting part. This is again related to collective stuff. This is what we want: parse button array subroutine. We will of course adjust it because it's overcomplicated here, because it's for the collective. So we'll call it parse button array tutorial device again, and we will send B to the function because it's the only thing we have here. Now this is the let's remove the commented out stuff because we totally don't need it. So here we have our function that will parse our button press. Parse button array tutorial device, and we remove everything except our B byte. So we remove these because we know that we only have 1 byte, so we can safely say it like this. It's some complex stuff, again it's a topic for another video, more detailed on how to do stuff with the multiple button sets with different types of physical controls. So the way of reading the button is the same for every device out there. Here we go through each bit in a byte and read its value into V variable. So basically you can see that G to AB for 1 to H, last button state, it's to global variable, we will call it tutorial device here. G tutorial device last button state. So we don't have any modifiers or complex stuff here, so we'll just say it like this. So if V is different from its last state of the button that we store in this array for each button, this is again not needed at all. This is not needed because this is collective related. So we have set button line here. This is just what we need. We call tutorial GTD set button I here. So set button number I with value V. So we can safely you can see with right indentation set up. You can see that you can safely remove this because our actual if block ends here, so you can safely remove this stuff from here and you can move it here, yeah, like that. So one moment. Yeah, everything is correct. So now we just need to correct it here. G tutorial device last button state. Right. So what will happen here? So we read each bit of the byte B which we receive here. Then we write the value of each bit we read into V. Each iteration of the cycle we write our value of the current bit of the byte B into a variable V here. Then if V is different from its latest state we have stored in this array, then we set the button of the joystick to its current value, whatever it is, 1 or 0. We just if it's different we send it to our joystick object, and then we save its value for for further use. That's it, guys. We have just created the master controller part of our device. So let's move on to other needed stuff. So if at first we need to define to enable this device, see, because otherwise the whole block won't be loaded during the compilation stage. So we will go to device definitions here, and we will simply say define tutorial device. Then we will go to constants. Here we have to if you remember we have to state what is the tutorial device I2C address. So we go to configuration tutorial device and we say define tutorial device I2C address, and we set it to 100. And we have to check that of course we go to constants tutorial device, that configuration, and we have to check that it does not interfere with other stuff here. You can see there's no number 100, so yeah, we have it there. Then we have to look, we need to define this global variable because we have changed its name, so we should go to EA global where's tutorial device, and we should put it there, G tutorial device last button state, and we should specify its size like this. because we have a single byte, so it's 8 bits, and what else do we need to do? At this point, actually, we can just press the compile and check what we need to do. So you can see that it has an error. Oh yeah, it says the file, our joystick library can be used with the Arduino Uno, of course, because we have the wrong board selected. So of course we selected Leonardo and we selected Sport, and then I press compile, and now it will call an error that we have forgotten to describe the type of this variable. Okay, let's look into other. Okay, you can see that we have an error in some totally unrelated place. That means that we have forgotten here. You can see that we have forgotten something. You can see that we have error in psychic, but we haven't changed anything in psychic. That means that we have some error in one of our files, likely missed, bracket or something. Here it is likely. Yeah, much better now. And now we can look. Nope, still we have this here. Yeah, we don't have to have semicolon after defined statement. So let's check everything we have written so far. Device definitions tutorial device is fine. Configuration tutorial device, nothing in here. Constant tutorial device is fine. Global vars tutorial device is fine. Let's yeah, I haven't used the Arduino IDE for a while, and slightly forgot how to do stuff. It's let's look at how it's done in here. Yeah, so everything is fine. We have just we have done it correctly. You can see it is similar. So our error is definitely in here, and the error is likely the missing or extra parenthesis. So I reckon it's this one. Yeah, how can you know that the error is not in the psychic, or that the error is indeed in here? You just go to the device definitions file and press the compile. And now you can see it compiles. So the error is definitely on our tutorial device tab. We just need to find it. Here is good. Here it's good. Here it's good. Yeah, and here we can see that we have lost our parents here. So this is have to be here. Okay, now it is correct. You can see that everything is lined up. Now it should compile. Alrighty then. It has another error. So let's look. You can see that our code to the sub is the same as we have it. Interesting. I'm not sure what's happening here because everything seems right. Oh, I see. Yeah, we have coded outside of the poll sub. Of course, it's not correct. So we should have, yeah, I see now. We should have our parents of the poll sub here, our closing parents, and yeah, here. Now it should give us another error because we have forgot to add our setup and poll call to our setup, and it didn't give us an error because it's not an error, but if you flash the master controller at this point, you can do it actually. This is interesting. Not sure. Let's undefine it and look what happens. We need to check if this error is caused by no. Yeah, okay, that's better. Let's look. We have probably, interfered with some device ID. 20 is probably taken, so let's take some other ID, like, and don't know, like maybe 50. Of course, we should enable our device back. Some Leonardos change their COM port number for some reason. You can see I have to select my port frequently. Yeah, now you can see we have 4 joysticks instead of 3, so we have likely interfered with something. Maybe the collective has port 20. So here's our joystick object, you see. But if you press the button here, something is not right here. Okay, let me look at it. Let's just restart it. Alrighty, I have it back here. Okay, so if we press the button now, nothing will happen. You can see this is because we have forgotten to call our poll and set up subroutines. So what we have to do is we have to go to setup body tutorial device, and we have to copy this block from here. We just have to change it to tutorial device, and we have to do the same thing with the pull function, because we go to main loop body, we just copy some block, and we go to main loop tutorial device, and we just change this here. We should okay, so now we can refresh. Wrong number again. Alrighty, and now, yeah, fun thing. A good way to test our device. So of course we had to plug it in first. Now it should work. And then we have to replug it. And it does not work. So let's debug it. That's why we have some serial print output in there. This is interesting, nothing happens. So define tutorial device. Let's add something here. Just to be sure it is code. For some reason it is not pod. So let's look again at what we have here in pod tutorial. Yeah, see, I have forgotten to change it here. So if defined tutorial device, and same thing I'm sure we have forgotten to do with the setup thingy. Yeah, let's check it now. Still nothing, but it is now called. So you can see that it is being called, but something is wrong with the reading process. Okay, this is interesting. Maybe it has something to do with the Arduino board being connected through, USB. I will try to unplug it. Well, still nothing. This is interesting. Let's go back to our peripherals file and look for errors there. You can see we are having some problems that you may encounter as well in your way, but there shouldn't be anything you can't fix. So it works here. So the problem is with our I2C communication. So it's 1 byte here. And everything seems correct. I might have some, physical problems with hardware tutorial device less buttons. Yeah. This is strange. Not sure what is happening really. Maybe it's a faulty cable. No, nothing. Strange. So that's interesting. I will try using another cable. It's unlikely to help, but who knows. Oh, I see what the problem is. Or not. Oh no, no, everything is fine. Yeah, finally. It's not sure what it have been. You know, maybe my bad soldering. So now we definitely receive the reading from our slave, from our device. So I see. Maybe we have to, uh, yeah, of course. Sorry, guys, I have forgotten how to use it. Uh, sure, because we have this defined inside of a while loop, it will be. We have to, yeah. We are redefining it inside of our while loop and expecting it to be non-zero. Of course, it won't work. So yeah, sorry guys. It's been like quite a while since I have used the Arduino stuff. So I'm kind of making absolutely stupid errors, and forgive me for that, but the point of this video is now to show you the organizational structure files and not the programming, or finally, so what we have here, the button works. The button works, and we almost have our joystick now perfectly incorporated into the whole structure of Simchair firmware. So let's look. Of course, if we don't have any configuration for this such a simple device, but if we had, we would have put it here. Some some notes about how to make it even better. if you look at the global vars, you can see that everything is under if defined blocks, so we will save some memory. Let's do this like that, because you know it's a better way than simply defining everything like this. So if defined tutorial device, so yeah, you can also add such a block you know, in there, but no, not there. Structures configuration, yeah, everything we need is there now. So guys, that's it. Our device is completely fully functional, and I will show you what was the point of making let's see, after device needed today, it starts working flawlessly. Now let me show you guys why we are doing it in such a way. So we have our Simchair directory here, and its copy is there. So let's imagine that you want to update your software. You just download it from GitHub, replace your files, and you can see that your files that we have added for our tutorial device are all there. So if now we will refresh our board with this updated firmware, it still works. So that's the whole point of you know, having to mess with, you know, separate files for our devices. So that's it, guys. I hope this video will be useful for you. I think I can see now that we need to have some more videos about you know, using buttons, potentiometers, encoders, and stuff like that, and head switches, mini sticks, etc. So I think it will be a series of videos, one thing at a time. For now, structure wise, I think this video may be quite useful, although I understand it's probably very hard to watch, but if you will struggle with something, you will likely find you know, your answer here in this video, because as usual we've had all kinds of problems during this you know, filming this video. Thanks for watching, guys. Please write in comments if it's tolerable at all, and if this video was useful for you, if you know, if your understanding of the structure of Simchair files and how to use it for your own joysticks improved any, if any, you know, if it did. Again, thanks for watching. See you in the next videos. Bye.